Welcome you all for the next session of digital electronics. Till the next previous class, we were seeing the parallel adder, decimal adder, and off adder, full adder. Those kind of adders we were seeing, and in all those kind of sessions, we were seeing only the addition technique, but we never discussed about the subtraction part. For example, like we were seeing only the unsigned numbers. Currently, we are going to look into signed numbers, that are negative numbers. Now, how the negative numbers are going to perform those kind of operations, and what are the techniques that we need to use to perform operations on negative numbers, we'll see in this particular session. Okay. So, the negative numbers are called as signed numbers. Now, why signed numbers? Why? Because for negative numbers, we definitely place a negative sign in front of a number. So that's the reason we call them as signed numbers. Now, signed numbers can be represented using three forms. One is sign and magnitude, second one is 1's complement, and third one is 2's complement. These are the three formats through which we are going to represent the negative numbers. Now, how we are going to represent using sign and magnitude? For example, if I am having a number called 1001 or 001. Now, the same number can also represent as 010101. This is called as least significant bit. This is called as most significant bit. This as MSB, most significant bit. This as least significant bit. These particular bits means the MSB bit is going to tell me whether the number is positive or negative. Means if it is a positive number, MSB bit should be 0. If it is a negative number, my MSB bit should be 1. So this is what I need to have for a sign and magnitude. For example, if I am having a number called 10001, so my MSB bit is 1 and my magnitude is, this is my sign, this is my magnitude. My sign bit is negative and my magnitude is 001, that is minus 1. For example, if I am having 00010, my sign bit is positive. This particular number is 20010 plus 2. If I want to represent plus 10, so this will be 0 as my sign bit. My 10 will be represented as 1010. If I wanted to represent minus 10, then this will be, sign bit will be 1 and my magnitude will be 100. So this kind of representation goes for my sign bit representation. Whereas for my 1's complement technique, to represent the 1's complement technique, I just need to replace a 0 with 1 or 1 with 0. Means if I am having a binary bits like this, if I am having a binary bits like this 10 10 10 110, if this is my given stream of bits, I want to apply 1's complement technique for this one. I want to apply 1's complement technique. So what I need to do, I need to replace 1 with 0 and 0 with 1. Means this one can be this can be shown as 1 is replaced with 0, 0 is replaced with 1, 1 again with 0. So this goes around like this, 10 10 0 1 0 1. So this is my 1's complemented value. Now we apply this 1's complement or 2's complement only for negative numbers, whereas sign and magnitude will occur for both positive numbers and negative numbers. Similarly, one more example for 1's complement. If I wanted to represent 01 01 111 01, I wanted to perform 1's complement to it. So what can be done? Replacing 0 with 1 and 1 with 0. So this can be 10 10 0 0 0 1 0. Just replace 0 with 1 and 1 with 0. So this is what the 1's complement technique is. Now coming to my 2's complement. 2's complement is 1's complement plus 1, which gives me a 2's complemented value. How I can find out a 2's complement of 1 0 1 0. If I wanted to find 2's complement of this 1 0 1 0, first I need to perform 1's complement on it. First I need to perform 1's complement on it, so that this becomes 0 1 0 1. Now for this 1's complemented value, I should add 1, so that to get my 2's complemented value. So I am adding 1 to my particular number, 1's complemented value. So 1 plus 1 will be 0 with carry 1. 1 plus 0 will be 1, 1 and 0. So 1 0 1 0 2's complemented value is 0 1 1 0 is my 2's complemented value. So this is what the conversion goes. For example, one more example we'll take. We'll take 0 1 1. I want to perform 2's complement on this. So first I need to perform 1's complement. When performing 1's complement, this becomes 1 0 0 0. Add 1 to this. What happens? 0 plus 1 1, 0 0 and 1. So this is your 2's complemented value. 2's complemented value for 0 triple. So this is what you need to do for complement technique. You are going to apply the 1's complement technique or 2's complement technique only for negative numbers. Now this can be done for both positive as well as negative. Then let's get into the next topic. Now let's see how the subtraction of numbers goes with 1's complement technique. We'll do with examples. Now 1's complement technique. Basically, let's have one more example. If I'm having 1 0 1 0 1 0, so 1's complement will be 0 1 0 1 0 1. Now just replacing 0 with 1 and 1 with 0. Let's use the same technique in subtracting two numbers. Why? Because I told you that 1's complement or 2's complement is used for subtraction of binary numbers. Let us perform subtraction of 15 minus 12 using 1's complement. Now 15 can be represented in binary as 4 1's. 12 can be represented as 1 1 0 0. So what I am doing 15 minus 12, my answer should be 3. That is 0 0 1 1 should be my answer. Now when I am performing 1's complement, I need to have some steps to follow it. First one, whenever there is a given negative number, first I need to convert this negative number to positive number. Means minus 12 should be applied for 1's complement technique, so that this becomes positive number. So 12, that is 1 1 0 0 should be applied 1's complement technique for negative number. So this becomes 0 0 1 1. Now you converted this place minus 12 to plus 12. Now add 15 and 12 when with the 1's complemented value. Now 15 now you can represent it as 1 1 1 1. Now 1's complement of 12 can be written as, that is 1's complemented value of 12 is 0 0 1 1. Now I am adding these two numbers. Now here 1 plus 1 gives me 0 1. 1 plus 1 0, 0 plus 1 1 with carry 1. Next 1 plus 1 0, 0 plus 0 is 0 with carry 1. Next 1 plus 1 0, 0 plus 0 is 0, a carry is been generated. Now this carry, if carry is generated when subtraction, then the number is positive number and I should add that carry to my result. What is my result? My result is this one, right? 0 0 1 0 is my result, and to this result I need to add this particular one. So I am adding this 1 to my result. So it becomes 0 plus 1 is 1, 1 0 0. So this is my answer. That is 3 0 0 1 1. So this is my required answer. Whenever carry is generated, the result is positive number and I should add that carry to my result whenever you are subtracting a higher number minus lower number. Now we'll see the other version, that is 12 minus 15. Now when you are doing lower number minus higher number, same thing. First 12 1100, 15 as 1111. Now I need to apply 1's complement to my negative number, that is 15. So this becomes 4 zeros. Then now this 4 zeros should be added to 1100. What happens now? This becomes 0 0 1 1. Right? So there is no carry generated. When no carry is generated, my result is a negative number and the result is in 1's complemented form. So this is in 1's complemented form. So I need to perform 1's complement to my result again now here. This is a negative number and I should perform 1's complement on it. So what it is? Minus of 1's complemented value, that is 0011. So this is minus 3. So I need to get here 12 minus 15 is minus 3. So this is how the two things which are there under 1's complement technique. When carry is generated, it is a positive number and I should add that carry to the result so that I will get my result in 1's complement. When no carry generated, the result is a negative number and it is in 1's complemented form. So minus of that 1's complemented value gives me that value. Let's get on to 2's complement. So this is your 2's complemented value. Now, when I am performing 2's complement, for example, if I am having 1010, I need to perform first 1's complement. So 1's complement thing will be 0101. Add 1 to this. 1 plus 1 is 0. 1. Again 1 here. 1 and 0. So this is your 2's complemented value for a given number. So that is 2's complement is equal to 1's complement plus 1. So we'll end up our session here.